Hello and welcome back. Let's talk about how to take the inverse of a matrix. So, the inverse of a matrix sounds a little scary maybe, and truth be told, it is a long process, but it's really nothing that we haven't really seen before. This is the last video in this first section of linear algebra. The next video we'll be getting into lines and planes, so very exciting, some 3D space stuff. If you're taking vector calculus or multivariable calculus, it'll be very useful. But let's not drag the video on. So let's get into what is the inverse of a matrix. Well, first, let's talk about what is the inverse in regular algebra. So if we had x, and x is just a variable in this case, we're not talking about linear algebra quite yet. But if we had x, and we multiplied it by x to the -1, or you could think of this as the inverse of x. What you're going to get is x, and then remember, you can just bring this down, make it 1 over x, and this is just x over x, which is just simply 1. Now, what is an inverse matrix? Well, an inverse matrix, if we have the matrix A, and we multiply it by a to the -1. Now, we shouldn't be calling it that. We should be calling it the inverse matrix of A. You might think that we get 1. But remember that when we multiply a matrix, we're going to get another matrix. So what we're actually going to get is, say these were both 3 by 3 matrices. What we're going to get is 1, 0, 0, 0, 1, 0, 0, 0, 1. For a 3 by 3 matrix. Of course, a 4 by 4 matrix, you're just going to have 4 1s, 5 by 5, 2 by 2, whatever, right? Well, what does this mean? Well, this looks familiar, doesn't it? This looks like the product of Gauss-Jordan elimination. What we actually call this matrix is the identity matrix, I. So our final formula here is a to the a -1 equals I. But how do we find the inverse of a matrix? Well, kind of complicated. We remember with determinants, we found cofactors. If I find the cofactor of, say I have a matrix A, let's just jump right into an example. Or no, we won't do an example quite yet. Let's say I have a matrix A, and it's got your 3, whatever, 3 by 3 matrix. These could be whatever. They don't have to be the same thing. But I can take the cofactor of this and then put it into this new matrix that we're going to call the matrix of cofactors. And, so this is the cofactor of this is the cofactor of this, so on and so forth. And so we get to this formula for the inverse of a matrix, that is 1 divided by the determinant of A times the matrix of cofactors transposed. Now, I hope you remember what A transpose is, because we will still be working with this in the future. But this is a very important thing to know, is the inverse of a matrix. Now, this might seem like a very strange formula, and I don't blame you because it is. But let's say we have a 2 by 2 matrix. Well, we have a special case with 2 by 2 matrices. This one I'll fill in with actual values, A, B, C, and D. Well, the inverse of this matrix is 1 divided by the determinant of that matrix times, let me make sure I don't get this right, or don't get this wrong. We switch A and D, and we put a negative in front of C and B. And that's the inverse of a 2 by 2 matrix. One last way we can determine the inverse of any matrix is this. Well, we know that A times A inverse is the identity matrix. Well, what we can do is we can put A on this side and I on this side of an augmented matrix. Let's say there were 3 by 3, you'd have 3, 3, 3. You'd have a 6 by 3 augmented matrix, or 3 by 6, sorry, rows before columns. And we can solve this using Gauss-Jordan elimination to try to make this side look like I, and what we're going to get on this side is the inverse of A. And that comes simply from this formula. So let's look at an example. Okay. Now, where did this go? I believe. Okay. We're going to let A equal. I need to make sure these. Yes. Okay. 1, 0, 1. 2, 1, 2. 4, 1, 5. Okay. Now you can pause this and try to solve this either way you like. I'm going to solve this using the cofactor method. So the cofactor at 1, 1, which is here, is positive. It's going to be 5, or 1 times 5 minus 2 times 1. So that's 3. C1, 2, well this one's going to be negative. And if you look back into the determinants video, you'll see why it is negative. What we're going to get is 2 times 5, 10, minus 8, which is 2, but remember it's negative, so we get a negative 2. Now I'm not going to go through all of these cofactors, but I will just write out what I solved before this video. Oh. C2, 2, C2, 3, C3, 1, C3, 2, C3, 3. Okay. What we've got is this. 1, 1, 0, 1. Okay. Here is our cofactors of this matrix. Let's make a matrix of cofactors. 1, 1, we've got 3, 1, 2, so first row, second column. We've got negative 2, first row, third column, negative 2. And we're just going to keep going. 1, 1, negative 1, negative 1, 0, 1. Okay, we've done most of the work here now. So our matrix of cofactors is looking right to me. Our matrix of cofactors transposed is 3, 1, negative 1. We're just bringing this and flipping it up, bringing this, flipping it up. Negative 2, 1, 0, negative 2, negative 1, 1. Okay. Determinant of A. Well, you guys can do this yourself. I chose this example specifically because the determinant of A is 1. So, 1 divided by determinant of A is 1 over 1 times C transpose. Well, this is our inverse matrix right here. So boom. It really is simple, but just a lot of work. Now I challenge you guys to try to do this the Gauss-Jordan elimination way. And truth be told, actually I think I have it here. Here we go. If you guys can see that, there was my solution to that way. So pause the video there, look at my work. Of course, I skipped a few steps because Gauss-Jordan elimination, once you get comfortable with it, it becomes a lot quicker of a process. Thank you for watching this video. I'm excited for you guys to learn the next unit. I quite liked it actually. But yeah, we are nearing the end of the course. I think there's about 10 videos left, so we're about halfway. So thanks for watching.